Lesson 83, more coin problems. So we've been given some problems. We've been given our equations to solve with substitution and elimination. This time we're going to actually set up our own equations and solve using substitution and elimination using our coin problems where we use the subscripted variables. So we are given in example 83.1. Why it's not working on me. My pen's messing up. Here we go. There it goes. 83.1 tells us that Jack and Betty have 28 coins, and they are nickels and dimes. So we have a number of nickels and a number of dimes, and there are 28 of them total. And it says that the number of nickels plus the number of dimes equals 28, and the value of the nickels plus the value of the dimes equals 195 cents. It says if the value of the coins is $1.95, how many coins of each type do they have? So when we're talking about coin problems and we're talking about the value of our coins, to avoid decimal numbers, we will just write the value in cents without putting in a decimal to show dollars. And that makes it a lot easier to calculate when we're just dealing with whole numbers and not decimals. So we're going to do that now. We know that nickels are worth 5 cents. That's nickels, not dimes. So nickels. And we know that dimes are worth 10 cents. That's the number of dimes we have. And we know that together that the number of nickels times 5 plus the number of dimes times 10 is $1.95. We're going to write it as 195 cents. Okay, now we can solve this either by substitution or elimination, and we should get the same answer. So let's go ahead and do that now. Let's do substitution first. So we're going to say, first we need to get this into a format that can be substituted. So let's solve for the number of dimes. The number of nickels. Let's solve for the number of nickels. We'll just subtract the number of dimes from both sides. So that turns into the number of nickels equals 28 minus the number of dimes. So because we just subtracted the number of dimes from both sides, which was the opposite of this, okay? So we can sub this value right here in for 5 and n. So let's do that now. 5 times 28 minus the number of dimes plus 10 times the number of dimes equals 195. All right, 5 times 28 is 140. And 5 times negative number of dimes is negative 5 times number of dimes plus 10 times the number of dimes. All right, let's subtract. Let me go ahead and finish. We subtract 140 from both sides. And we'll combine these two. And that's going to cancel. And negative 5 and positive 10 is positive 5. So 5 times the number of dimes equals 195 minus 140, which is 55. So the number of dimes is 11 because 55 divided by 5 is 11. So if we sub that in to our original problem, the number of nickels plus 11, because that's the number of dimes, equals 28. And we subtract 11 from both sides. Then we know that the number of nickels, there were 17 nickels. Okay, so that's substitution. Let's try elimination. So in order to do the elimination, we need to bring one of these variables up to match the other. And the smallest one is 5, and I always like to do the smallest one. So we're going to multiply. Let's write our original statement. 5 number of nickels plus 10 times number of dimes equals 195. Now we're going to do negative 5 so that we have an opposite to eliminate. Negative 5 times nn is negative 5 nn plus negative 5 times the number of dimes is going to be not plus but minus 5 times the number of dimes. And negative 5 times 28 is going to be negative 140. All right, we've seen these numbers before. That's a 0, not a 6. All right, so this cancels. This becomes 5 times the number of dimes equals 55. The number of dimes is 11. We sub in again. Number of nickels plus 11 equals 28. We subtract 11 from both sides. We know that the number of nickels is 17. Same answer. Both methods give us the exact same answer. So that is a pretty good indicator that those answers are correct. Now, if you wanted to, you could go back and check your work by saying, okay, 5 times the number of nickels, which is 17, that's going to be 85 cents, right? That's going to be 85. Plus 10 times the number of dimes. We had 11 dimes, so it's 110. Does that equal 195? It does. 85 and 10 is 95. So 195, that's correct. So we got the same answer for both. We checked our answer, and it's correct. So we are confident that substitution and elimination works, given that instance. All right, let's jump into 83.2. Let's see what we have here. Ming has $4.45 in quarters and dimes. Okay, so let's rewrite this. We have quarters and dimes, so it's 25 times the number of quarters plus 10 times the number of dimes equals 445. All right, that's how we would write that problem. She has 8 more quarters than dimes. How many coins of each type does she have? So she has 8 more quarters than dimes. All right, so that means that the number of dimes, she has more quarters than dimes. So the number of quarters is equal to the number of dimes plus 8. Because she has 8 more quarters than she does dimes. All right, so that's something we can work with. We can solve this really quickly with, we could solve it with either problem, but I think that substitution is going to be faster because it's already set up, solved for the number of quarters. So we can just sub in 25, number of dimes plus 8, plus 10 times the number of dimes equals 445. Right? So now we can just do the multiplication, and we have 25 times the number of dimes plus 200 plus 10 times the number of dimes. Okay, that equals 445. We could subtract 200 from both sides, and we can combine these two. This is going to be 35 times the number of dimes equals 245. So we can divide both sides by 35. And we know that the number of dimes is equal to 7 because 245 divided by 35 is 7. Now we could sub that back in to our problem here, and we know that the number of quarters equals 7 plus 8. So the number of quarters is going to be 15. Easy peasy. It's all about listening to your word problem and being able to write an equation based on your word problem. Let's try example 83.3. Orlando had a hoard of 22 nickels and dimes. So the number of nickels plus the number of dimes was 22. Okay, we heard that, right? Orlando had a hoard of 22 nickels and dimes, whose value was 135. So value, now value. 5 times the number of nickels, that's the value of the nickels, plus 10 times the number of dimes, that's the value of the dimes. Okay, the value was 135, $1.35. How many coins of each type did he have? So we can use, let's use elimination this time, and let's multiply by -5 here. So let's go ahead and just bring that down and do that here. So 5 times the number of nickels, -5 times the number of nickels is -5 times the number of nickels. -5 times the number of dimes is -5 times the number of dimes. And that equals -5 times 22 is going to be -110. So we can eliminate that. We're left with 5 times the number of dimes equals 25. All right, and if we divide both sides by 5, we have that the number of dimes was 5. So now we can solve up here. The number of nickels plus 5 equals 22. We subtract 5 from both sides. Then we know the number of nickels was 17. Solved. Okay, let's keep going. Let's do one more. Do we have one more? No, that was the last one. Oh, goodness. I was kind of having fun with that. All right, so as you could see, you listen for the total number, and the total number of coins is just going to go with your NN and your ND. Then when it says the value of those coins, that's when you write the value of the coin times the number of the coins, right? The value times the number, and then the total value of the coins. So that's going to be how you set up and what you listen for. The total number of coins is just the plain variable. The total value of coins attaches the value times the variable for those coins, okay? All right, if you can remember those two things, then you won't have a problem setting up your equations for substitution or elimination. That's all I have for lesson 83, and I will see you in lesson 84.